Verifying identities. So whenever we're verifying identities, there's some steps here, as you can see listed on the process. So you definitely want to solve one side of the equation, especially if you're given two, to simplify the other. Some expressions can be simplified quickly and rewritten. Some may take a little bit more work. You have a rational expression. So let's just solve these. So example 1 says that you're giving these two binomials times each other. And if you notice in the binomial, the first terms are identical, the last terms are identical, but the signs are different. So we have a difference. So I can use this shortcut of a squared minus b squared, where a is my first cosine, beta squared minus my b, which is the last, the cosecant of beta. And I can rewrite this. And what happened? I just solved it. So my answer here is A, as you can see. It's been too bad. Our next one, find a statement that completes the identity. So we have sine x minus cosine x all divided by cosine. So I can rewrite it where I have sine x over cosine x minus cosine x over cosine x. Well, sine x over cosine x, we know is tangent x, and then cosine divides by cosine is 1. And what do we get? We get B. Our answer is B. Example 3, find the product and simplify your answer. So if you notice, the first terms are the same, the last terms are the same, but the signs are different. So we're going to use that shortcut again, a squared minus b squared, where we get secant x squared minus 1 squared, which rewritten as secant squared x minus 1. Now we're going to have to go back to our identities and to determine what's our final answer here, right? So we have to simplify it if possible. Well, when I go back to my identities, I see that I have 1 plus tangent squared x that involves the secant squared x. So I just need to solve for tangent because I need secant squared minus that 1. So I'm going to subtract the 1, and now I know my answer in simplified form. Okay, let's go to our next one. Our next one has this binomial being squared. So that means we got two identical parentheses. 5 secant x plus 2 times 5 secant x times plus 2. So that means we're going to use the full method. We're going to say the first times the first. So that's going to be 5 times 5 times secant x times secant x. I'm going to put a plus, and then we're going to have our outers. So now I have 2 times that 5 secant x. We're going to do our inner. So now I have plus 2 times that 5 secant x. And then we're going to have our last. It's going to be 2 times 2. So now I have 5 times 5 is 25. Secant times secant is secant squared. 2 times 5 is 10. Secant x. 2 times 5 is 10. Secant x. And 2 times 2 is 4. And now I have the middle. I have 10 plus 10. So I have 25 secant squared x plus 20 secant squared, or secant x plus 4. And that is my answer. Oops. There we go. Okay, the next one. Prove that the following equation is an identity. So here's the one I said that sometimes you have to solve one side of the equal sign. So I'm going to solve this sign to see if it matches the other side. So let's work on this just a little bit. I noticed that in the denominator of tangent x and secant x, so I need to multiply each side by the missing part. So I have a like denominator and I put it all over one denominator. So this first one needs to be multiplied by secant x over secant x. And then the second one's going to be multiplied by tangent x over tangent x. All right. So now when I do this, I can clean it up. It's all going to be over the same denominator. And if you go to our identities, you'll find that 1 equals secant squared x minus tangent squared x. So now I have 1 over the tangent, or you can, it doesn't matter on the order, tangent x secant x. So when we write that, this is what we got in the end. So now let's look at it. I'm going to just switch this order. It doesn't matter because 2 times 3 is 6, 6 times, or 3 times 2 is 6. So the order doesn't matter. I'm going to go ahead and just write the secant first and over 1. So I can rewrite it 1 over secant x times 1 over tangent x. And what do I know about that? Well, I know that 1 over secant x is going to be the cosine because it's the inverse of it. And then tangent is going to be cotangent x. And that is my answer.